Hello everyone. So this is the part 2 for the video on the chapter 9, so which is on the deflection of the beams. But in this video, so I will focus on the examples on the simply supported beam, in which we will do two different examples on how to derive the elastic curve equation and solving for deflection and beam slope on a simply supported beam. Alright, so let's start. So this is the first example in which I want you to try together with me. So let's say we have a simply supported beam of ABC that is shown here. Alright, so the total length of this beam is L, and we have a loading of P at L/2. So the first question is asking you to find the elastic curve equation for this beam. Alright, so whenever you encounter this type of question, so what you need to do is always find the reaction, okay, so at A and also at B. So we know that we have RA here and we also have RB here. So you can use the equilibrium, okay, so to find this value here. Okay, so let's try to find it on your own first. You can pause the video and in order for you to find this value of RA and RB. Alright, so did you manage to find the value? So if you use the equilibrium problem, okay, so you can get the value of RA and RB, because this is a symmetrical, so is equal to RB is equal to the P/2. So we know that over here, so the value of the loading or reaction at RA and RB is P/2. Alright, so now we can proceed to find the moment equation. Okay, so in this case, so what you need to do is to find the moment equation for the length of point here, so in which we can cut off this point here. Okay, and then we can determine that the value of x, okay, so the distance of the moment that we need to find is in between 0 and also L/2. Okay, so then we will get a beam condition in which we have a RA over here, which is equal to P/2, and then we will have a moment here that we need to determine the value of the moment here, and also we have a V here. Okay, so which is unrelated, but it is nice to have. All right, so now we can solve for the finding the moment equation here. So you can try it on your own first, because this is really simple. Okay, so you can pause the video again and find the value for M. Alright, so did you manage to get the value for the M? So you should be able to find using the equilibrium, and you can find the value of M is equal to minus RA times the value of X here is equal to 0. So our M is equal to RA times X, so which is just Px/2. So we will use this value of M in order to find our elastic curve equation. Alright, so once you got the value of the moment that we can use to derive the elastic curve equation, so which is M is equal to Px/2. Then we can proceed with finding the value of the elastic curve equation using the double integration method. So first we need to get the equation as EI d square y over dx square is equal to Px/2. Alright, and then we can integrate this value once to get the slope, so which is EI dy over dx is equal to Px square over 4 plus C1. Okay, and we can further integrate this value once again, so SEI y is equal to px cubed over 12 plus C1x plus C2. Alright, so based on this equation, so we have two unknown, which is C1 and C2, and we need to solve this unknown by looking back into this beam again. So previously, I have shown you the boundary condition, so we can put it over here. So over here, so the boundary condition will be x is equal to 0, okay? And we will get our y is equal to 0. So that is the first boundary condition. And the second boundary condition is x equal to L, y equal to 0. So now you have these two boundary conditions. So let's try on your own to put the value of this boundary condition and solve for C1 and C2. So you can pause the video once again and try to do it on your own. Okay, so from our question just now and the boundary condition, so we can solve for this one. Okay, so by using the first boundary condition in which x equal to 0, y equal to 0, okay, so we can get the value of C2 is equal to 0. Okay, so C2 is equal to 0. And for the second condition in which we get x equal to L, y equal to 0, okay, so we can solve for the C1 and we will get the value of C1 is equal to minus 1 over 16 PL square. Okay, so now we can put the value of C1 in C2 into this equation here and we will get EIY is equal to PX cubed over 12 plus minus PL square over 16, okay, so plus 0. Okay, so and then we can simplify, okay, so simplify this value here as y, okay, so y is equal to PL over 48 EI times 4x cubed minus 3L square times x. Okay, so this is our elastic curve equation. Alright, so now let's try to do the second question in which to find the value of slope and deflection at x equal to L over 2. Okay, so from the derivation that we did just now, so we can get the value of y is equal to PL over 48 EI times 4x cubed minus 3L square times x. Okay, and then we also get the value of dy dx in which we just put in the value of the C1 into the equation that we have done previously and you will get this formula here. So to find the deflection at C, so what does it mean by finding the slope and deflection at point C? So when we put the loading at C here, so we will expect this beam to deflected and curve downward this way here. So we have a value of deflection of y at C over here and we can find also the slope at this point here. So we can find the slope and deflection at x equal to L over 2 by just plug in this value into this equation here. Alright, so to find the y at C, okay, so we can just put in the value of PL over 48 EI times 4 times L over 2 cube minus 3L square times L over 2. Okay, and then we can simplify this value and we will get the value of minus PL over PL cube over 48 EI. And for the slope, okay, so for the slope at x equal to L over 2, okay, so we can put the value here, 16 EI times 4 L over 2 square minus L over 2, okay, so we will get 0. And this is understandable because for this beam, so the maximum value of deflection is happening at C, and the tangent at this point here to find the slope is 0. Alright, so this is the end for the first example. Alright, so now let's start with the second example, in which we have a beam of length L, and it is supported at A and B. But unlike the previous example where the P is symmetrical, so now we have a P at L over 4 from A. Okay, and the question is asking you to find the slope and the deflection at point D here using the double integration method. Okay, so as usual, so whenever we have a beam, okay, and we need to derive the moment equation, so we need to determine the value of RA here, okay, and RA and also RB. Okay, so you can use the equilibrium equation and try to find the value of RA and RB. So let's pause the video and then find the value of the reaction. Okay, did you manage to find the value of RA? So if you get the value of RA is equal to 3 over 4P, and the value of RB is equal to P over 4, so then the answer is correct. Okay, but because this is unsymmetrical, so we need to have two situations in order for us to solve for the elastic curve equation. So the first equation, okay, is for the moment of x less or equal to L over 4. Okay, so for the situation where the x is less or equal than L over 4, then we can get the value, our free body diagram. Okay, so let's say this is our x. Okay, and then this is our RA, which is 3 over 4P. Then we have our moment here that we need to solve. Okay, and we can solve for the value of moment here is just equal to M minus 3 P over 4, 3 over 4P times x is equal to 0. Then our M is equal to 3Px over 4. So that is for the first moment equation. Then once we get the moment, okay, so we can further proceed with the double integration. So in which we have EI d square y over dx square is equal to m, okay, which is 3px over 4. Okay, so let's continue to integrate this once to get the value of the slope dy dx is equal to 3px square over 8 plus c1. Okay, and the second equation, which is the second derivation, the second integration, so it will be EIY is equal to 3px cubed over 24 plus c1x plus c2. Okay, so that is for the first reaction. Okay, so for the second situation is from when we have the value of x is bigger than L over 4. So when we have x equal to L over 4, okay, so we can expect our x, our beam, to have RA is equal to 3 over 4P, okay, and our P, which is situated at L over 4 here. Okay, and then we can find our M. Okay, then we can use the equilibrium to find the value of M, which is equal to M minus 3 over 4 px, okay, plus p, okay, so x minus L over 4 is equal to 0. Then we can get our value of M, okay, so let's denote this as M2 is equal to 3 over 4 px, okay, so minus px plus pl over 4. Okay, so this is our second equation. And then we can further simplify this. Okay, so this will become 3 over 4 minus px. So this is minus px over 4. Okay, so plus pl over 4. So let's integrate this. Use the double integration method to get the second elastic curve equation. So in which I d square y over dx square is equal to minus px over 4 plus pl over 4. So let's integrate this once to get the value of ei dy over dx is equal to minus px square over 8 plus pl x over 4 plus c3. And then the second one is eiy, okay, is equal to minus px cube over 24 plus plx square over 8 plus c3x plus c4. Okay, so we can denote this as the third equation, and this is the fourth equation. And the previous equation that we did just now, so this is the first equation, so this is the second equation. Okay, so now we have 4 equation and also 4 unknown. Okay, so for this case, so we need to have 4 boundary condition in which we have to have in order for us to solve for the unknown equation. Okay, so what is the value of the what is the value of the boundary condition that we need to have? Okay, so let's look back into this equation here. So we know that here for the simply supported, we know x equal to 0. Okay, so y is equal to 0. So that is the first boundary condition. So the second boundary condition is equal to x equal to L, y equal to 0. Okay, so now we need 2 more. So for the second boundary condition is where they have a similarity. So when the beam is deflected, okay, so it will curve this way. Okay, so what we will have to have is, we know at this point here, okay, so at this point here is theta 1, okay, is equal to theta 2, okay, in which this theta 2 is denoted by this value here. Okay, so this is y2. Okay, and we know that y1, okay, is equal to y2. So now we have the third and fourth boundary condition, and this 2 is happening at x equal to L over 4. Okay, so we have 4 boundary condition and we also have 4 unknown. Then we can solve for the equation here. So let's try on your own, okay, to using this 4 equation. Okay, so 1, 2, 3, and 4, and use all these boundary condition that I have stated here to solve for the slope and deflection at point D. Okay, so you can take your time and pause the video to solve for this equation. Alright, so did you manage to solve for the equation? So if you have done it, so you will get the value of, we can put the value of x equal to 0, y equal to 0 in equation 2, Okay, so you will get C2 is equal to 0. Okay, so now we can put the second boundary condition, which is x equal to L, y equal to 0. Okay, so in equation 4, okay, so you will get the value of um, 0 is equal to 1 over 12 PL cube plus C3L plus C4. Okay, and then the next one, so we can put x equal to L over 4, in which we will have theta 1 is equal to theta 2. So that's mean, so the equation 1 is equal to equation 2 at x equal to L over 4. Okay, so we can proceed to get the value of 3 over 128 PL square plus C1 is equal to 7 over 128 PL square plus C3. Okay, and we can put the second one, the fourth boundary condition, in which at x equal to L over 4, y1 is equal to y2. So equation 2 is equal to equation 4 at x equal to L over 4. So we will get the value of PL cube over 512 plus C1 L over 4 is equal to 11 PL cube over 1536 plus C3 L over 4 plus C4. Okay, so now we have all this value, so we can solve for all these equations simultaneously, and we can get the value for each constant. So if you try to solve for the equation simultaneously, so you will end up with this value here. Okay, so C1 is equal to minus 7 PL square over 1 to 8. Alright, so C2 is equal to 0. Okay, C3 is equal to minus 11 PL square over 1 to 8. And then C4 is equal to PL cube over 384. So back to the question. So what is the slope and deflection at D? Okay. So at x equal to L over 4. Okay. So we can find our theta as EI theta 1. Okay. So from the equation 1 is equal to 3 over 8 px square minus 7pl square over 1 to 8. Okay, and then we can put the value of L over 4 over here. Okay, so if we put the L over 4 to this x here, so we will get the theta is equal to minus PL square over 2 EI. Okay, and for the equation 2, we can put EI y1 is equal to px cube over 8 minus 7pl square over 1 to 8x plus 0. Okay, and also against we can put the value of L over 4 into x here. So we will get our y as 3pl cube over 256 EI. So this is the value of slope and also deflection at point D. Okay. All right. So I hope you can try. Okay. So this question on your own. Okay. So once again, so if you have any problems, so you can let me know or you can ask into our WhatsApp group. Okay. So let's see you in the next video.